students! Welcome to our math class. I am Teacher Becca and I will be your guide all throughout this journey. Before we move on, I'd like to give you a short encouragement about our subject. A lot of students are scared to face mathematics, and the reason is because it's hard and complicated. I'm here to tell you that it's not what you think it is. If you're having a hard time, you're not alone. I'm here to help you. Let's do it together. What matters to me isn't your ability to solve, but your heart to learn. Always keep in mind that in order to gain the most, you have to know how to convert negative thoughts into positive ones. If this is the case, then it would be easier for you to learn mathematics. So, are you with me? Let's get started! For our first lesson, I'll be introducing you to quadratic equations. In this lesson, you will be learning how to appropriately define and illustrate a quadratic equation, correctly transform a quadratic equation to its standard form, and accurately determine the value of a, b, and c in a given quadratic equation. First of all, what is quadratic equation? You probably encountered equations like this before. 5x squared equals 0, 2x squared plus 3x equals 0, 6x squared plus 12 equals 0, and x squared plus 2x minus 6 equals 0. All of these are quadratic equations. In mathematics, quadratic is a type of problem that deals with a variable multiplied by itself. This is an operation known as squaring. This language derives from the area of a square being its side length multiplied by itself. The prefixes quadri and quadratus in Latin means four and square respectively. In ancient times, quadratic equations were originally utilized in dealing with problems involving squares. Since the second power is called a square, equations whose degree or highest exponent is 2 were named quadratic equations. Quadratic equation is written in the standard form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. Meaning to say, both b and c can be 0, but a should not be 0. Ax squared is the quadratic term, which is in second degree. Bx is the linear term, which is in the first degree, and c is the constant term. Constant term means a term with no variables. It is a fixed value. When identifying whether an equation illustrates a quadratic equation or not, it is necessary that you know how to perform operations involving polynomials. This will aid you in transforming a given equation to standard form. You also need your skill in identifying the degree of a polynomial. Like a quadratic equation that has a standard form, we humans also follow standard procedures and rules in our daily lives. As students, you are following standard rules in school, at home, and in the community you belong to. To easily identify the values of a, b, and c, we should make sure that the equation is written in standard form. Let's have some examples. First example, we have x squared minus 16 equals 0. Is this a quadratic equation? If your answer is yes, then you are correct. Obviously, the equation is in the second degree. Is it written in standard form? If your answer is yes, then you are correct again. However, you may be wondering why it is only composed of two terms. Going back to our definition, b and c can be 0, but a should not be 0. In this case, we don't have a linear term. Thus, a equals 1, b equals 0, and c equals negative 16. For variables with no numerical coefficient like x squared, it is assumed that the numerical coefficient is 1. Frequently, if the numerical coefficient is 1, it is not written at all. 1x squared will simply be x squared, and 1y will just be y. For our next examples, we will complete the table that follows. First, we will identify if the given equation is quadratic. Next, we have to make sure that the equation is written in standard form. If not, then we have to write it in standard form. Lastly, we will identify the values of a, b, and c. First example is 3x squared equals 0. 3x squared equals 0 is in second degree equation, so it is quadratic. Obviously, it is written in standard form, so we just copy it. Next, determine the value of a, b, and c. The equation has only one term, which is the quadratic term, so a equals 3, b equals 0, and c equals 0. Next, we have negative 4x squared plus 7x minus 7 equals 0. It is a quadratic equation and is also written in standard form. Thus, we can easily identify the values of a, b, and c. A equals negative 4, b equals 7, and c equals negative 7. Next example is x squared plus x equals 2x plus 6. First, we need to make one side of the equation be 0 by applying the addition property of equality. The addition property of equality states that if the same amount is added to both sides of an equation, then the equality is still true. To do that, I need to add negative 2x and negative 6 to both sides of the equation to make the right side of the equation be 0. So, it will be x squared plus x plus negative 2x plus negative 6 equals 2x plus 6 plus negative 2x plus negative 6. Next, we will combine similar terms. On the left side, we have x and negative 2x. Adding them results to negative x. Then we will just copy the remaining terms. On the right side, 2x plus negative 2x is 0. 6 plus negative 6 is also 0, which means that the right side of the equation is already 0. Finally, the standard form of the equation is x squared minus x minus 6 equals 0, where a equals 1, b equals negative 1, and c equals negative 6. Next example is 8x minus 9 equals 0. Obviously, it is not a quadratic equation since there is no quadratic term. Next is the square root of 4x squared plus 3x plus 8 equals 0. It is also not a quadratic equation because x squared is inside the square root symbol. If we get the square root of x squared, the result will be x, resulting to a linear term. Again, it is not a quadratic equation. Lastly, we have the quantity 2x minus 1 times the quantity x minus 3 equals the quantity x plus 5 times x minus 1. To identify if it is a quadratic or not, we need to apply the operations involved first. On the left side of the equation, we will solve the quantity 2x minus 1 times the quantity x minus 3 by FOIL method. So, 2x times x equals 2x squared, 2x times negative 3 equals negative 6x, negative 1 times x equals negative x, and negative 1 times negative 3 equals positive 3. Combining similar terms, negative 6x plus negative x is negative 7x. Thus, it gives us the answer 2x squared minus 7x plus 3. Moving on to the right side of the equation, x times x is x squared, x times negative 1 is negative x, 5 times x is 5x, and 5 times negative 1 is negative 5. Combining similar terms, negative x plus 5x is 4x, thus it gives us the answer x squared plus 4x minus 5. Next, we will make the right side of the equation be 0 by applying the addition property of equality. To do that, we will add the opposite of each term on the right side of the equation to both sides of the equation. So it will be 2x squared minus 7x plus 3 plus negative x squared plus negative 4x plus 5. Combining similar terms, we have x squared minus 11x plus 8. Since we are adding the right side of the equation with their additive inverse, the result will be 0. Thus, our final equation would be x squared minus 11x plus 8 equals 0, where a equals 1, b equals negative 11, and c equals 8. And that's it for today. See you on our next video. Once again, this has been Teacher Becca for ClickGen.